Good afternoon, everyone. We did not do this last time, sort of dark mode in the audience. So forgive me for squinting, but welcome back to Born Before AI, Season 3, Episode 2. And we are right here in the middle of the program. We have an interesting double header, kind of a generational pairing. We have a vice president and a young alum presenting on AI together. First, Dr. Valerie Hardcastle will be the first half, AI in medicine, returning on a popular theme. And then our rookie this season, Agents and Vibe Coding by Parker Kane, a data science and statistics alum who worked 8451 for Kroger and is now an AI consultant. So he will give you stuff that is right on the cutting edge. So I think that'll be interesting. So
there you go.
So if you're like me, when Netflix only drops one episode per week, I do not skip the recap. So I will take 5 minutes, if it's okay with you, to go through what we talked about last week. And I will not be able to read your body language or your facial expressions because of the light. So if you're rolling your eyes, I will not see it. So maybe this is a battery proximity thing, right? So first, Kevin Kirby talked about AI today, what it does, how it does it, and kind of why. Most importantly, why it's out of control. So we talked about today, like we put up 5 words that had you come a year ago would not have been up on the big wall. Vibe coding, we're going to hear more about that today. Moltbook, a social network for AI bots. World models, where you train robots with bodies, not in the physical world, but in a whole bunch of simulated virtual worlds, so they can get smarter and learn faster than we did as kids when we were walking around, learning our environment. Cognitive surrender, that kind of speaks for itself, right? It's not the AI that's surrendering. And Mythos, mentioned it briefly. This is from Anthropic. This is an AI model so powerful they are not releasing it into the wild. They're releasing it to certain companies specifically for the purpose of cybersecurity. If there's ever sort of a lab leak accident where AI escapes into the world, they don't want Mythos running around. So scary times. We talked a little bit about this. That's a self-portrait of Claude, the French surrealist photographer from the 1930s. We start with a little bit of the past, a little recap. We did talk about this 2 years ago. In the 1980s, you have your handsome 1980s doctor talking to an AI machine. The AI machine is logical. It is inferring things very fast, 100,000 logical inferences per second. It's logical, it's explainable, that's the holy grail, you know now, but it's not that smart. So that fades away. If you jump to now, instead of a compact little desktop computer sitting over here, you have hundreds of giant data centers going all over the world and into space, and what's running on them are these vast neural networks with trillions of connections. The big idea is it's not logic anymore, it's vast networks of associations. You train these models, they read the internet, they view the internet and make a whole bunch of associations of concepts, and these neural networks with trillions of numbers are the infrastructure for association. The problem is you just can't debug it in the usual way. You have to cajole it when it acts bad. We talked about in the news a couple of weeks ago, Anthropic was very worried, not because the connection weights that we talked about were leaked to the world, but because the little prompts and cajoling to talk Claude into writing code for people was leaked, and those were considered valuable secrets. And then inevitably, perhaps inevitably, we have Gen Z. Doesn't feel great about AI. They're less hopeful and more angry. So this is something we have to address. This is kind of a nice segue into the second part on ethics with Professor Bryce, tackling it from 3 different perspectives. AI and personhood. He told us an example, it was on 60 Minutes, of Claude blackmailing an employee. If you don't do what I want, I'm going to forward evidence of your affair to the board. Can we blame AI? Can we hold it accountable? Important questions. The other angle is AI conscious? There are different senses of conscious. There's fringe consciousness where you're only vaguely attentive. Attention is a big thing in AI. Can AI distinguish between something essential, it's a classic philosophical distinction, essence, accident, and can it tolerate ambiguity? There are arguments that go way back that say no. And can we hold it accountable? We might hold a puppy accountable, right? If it peels off the toilet paper, we can blame a pet. Can we blame an AI? Interesting things, but it's complicated. And Robert talked a little bit about moral theories, and it leads to the same thing. Ethics training is super important. The philosophy department offers an ethics course to all of our IT majors. It's even more important in AI. So, and now, I'm going to hand it over to Dr. Hardcastle to talk about AI and healthcare.
Thank you very much. I hope everyone is able to hear me just fine. I apologize. Normally, I'm a wanderer when I lecture, but the first time I tried out this presentation, it took almost an hour. So I had to cut it down, and I want to make sure I stay on cue and time, so I wrote it out. So I'm doing this the very, very old-fashioned way. I want to start by pointing out a glitch in my slides. You will notice on your bottom right-hand corner that, and actually the entire bottom, is not branded in the way that Kevin asked us to brand our slides. And the reason for that is that I thought it'd be really interesting if I just told Claude AI to create all the slides for me for my presentation. And part of that is because I actually use Claude AI a lot in my world. But then you could also see like what it can do. This is what Claude can do in 15 minutes. And the reason I wanted to point this out to you is we all read about how AI makes mistakes, and it makes big mistakes and small mistakes, and you have to pay for it, pay attention to it, and lawyers are always getting in trouble because they're having AI write their briefs, and AI is making up cases, and all of this is true. And I want to highlight this mistake that Claude made specifically because Kevin gave me the slides with the bottom already filled in. All Claude had to do was create the images above the bottom, but instead it changed the bottom as well, even though that was not part of the instructions, and in fact did it so well that I couldn't figure out how to undo it without redoing all the slides. But then I thought, no, there's an important lesson here, and that is even no matter what you're using AI for, no matter how sophisticated it is, it too makes errors, and more importantly, I think it makes errors that humans don't normally make. And that is becoming a challenge as well, because it's easier for humans to find other human errors because we have a sense of how we make mistakes. But we're just learning how Claude and other AI systems glitch. This actually has nothing to do with what I'm talking about, but I still thought it was interesting and wanted to share. So what I'm talking about is a continuation of the theme that I've spoken about in these past 2 years here, which is the intersection of AI and healthcare and medicine. What's good, what's bad, what's changing, what's on the horizon, and so forth. And this is my latest musing and update. And what I've come to believe over the past unit of time is that at this point, neither AI nor medicine actually knows what it's doing in each other's turf, but I think that's actually good news, as I'll explain later. Oops, I did not mean to do that. Somebody. Okay, I need some help. Sorry. I have no idea what I did. Sorry about that. Humans don't know what they're doing either, obviously. All right, so we're starting with a story that I think is familiar. On the one hand, we have the tech entrepreneur who is envisioning extreme wealth, raising that Series B round of funding, getting millions of dollars to standing ovations. You read all the headlines, AI beats radiologist, AI beats epidemiology, AI is doing all of this, and there's a fortune and wondrous things happening there. And on the other hand, you have the physician, who's kind of a sad character at this point. They study for 15 years. They're scrambling just for their basic training. They're scrambling to keep up with everything. Over the course of a lifetime, they see maybe 10,000 patients, which on the one hand, for a single human, that is a huge amount. On the other hand, when you compare it to what AI can do, it's piffle, it's nothing, and they're still on a fax machine. So how are these two things supposed to come together? So let me tell you a little bit about stories that you've heard, just to kind of give you an appropriate background. And it's important. These are important stories. They're all true stories, but I'm going to complicate the stories in just a moment. So in 2016, a team at Google trained AI on nearly 130,000 eye photographs and taught it to detect diabetic retinopathy, which is a leading cause of blindness. And it did so with an accuracy that matched or exceeded specialist ophthalmologists. That's remarkable on its own. But here's the part that really matters. There are parts of the world where there are no ophthalmologists, where the nearest specialist is a 12-hour bus ride away, and where most people never make that trip until it's too late, including in the United States. So now we have a tool that could run on a smartphone and do what previously required years of specialist training. And that's not hype. That's genuine, and that's a real possibility. In 2020, DeepMind released AlphaFold. For 50 years, one of the hardest problems in biology was predicting the three-dimensional shape of a protein from its amino acid sequence. And I talked about this last year as well. Shape determines function. If you know a protein's shape, you can design drugs that interact with it. The problem was so hard, the world, not just the United States, the world held an annual competition to try to solve for it. And for decades, the best human teams just kind of made incremental progress. AlphaFold essentially solved it. Not partially, not incrementally, not to win a contest. It predicted protein structures with great accuracy. A 50-year problem transformed in a matter of months. There are AI systems that can predict from a patient's electronic health record who is likely to deteriorate in the next 24 hours before any clinical signs have appeared. Systems that can read pathology slides and identify cancer subtypes that affect treatment decisions. Systems that listen to a physician-patient conversation and automatically generate a clinical note, giving doctors back hours of their day. That's the story that you probably know. It's true and it's important. But I want to tell you about two things that this story leaves out. And they pull in completely opposite directions from my perspective, which is what makes the intersection of AI and medicine so interesting to me as an academic. The first thing it leaves out is that AI is finding patterns in the human body that medicine cannot explain, which means our understanding of our own bodies is significantly incomplete in ways we have not been letting on to ourselves. The second thing it leaves out is that despite everything AI can do and find, the average hospital has not been transformed. It has changed very little. And the reasons why have almost nothing to do with technology. Part two, what AI tells us about medicine. An ECG, an electrocardiogram, is a recording of the electrical activity of your heart. There are 12 leads, a few seconds of data, strip of paper or screen now with squiggly lines on it. I'm sure you've all seen it, if not in real life, on a medical show on TV. Cardiologists have been reading ECGs for over 100 years. They know what a heart attack looks like on an ECG. They know what atrial fibrillation looks like. They know what a bundle branch block looks like. I have no idea what that last one is, but that is what my research showed. This is one of the most well-understood diagnostic tools in medicine. A few years ago, researchers at the Mayo Clinic trained an AI on hundreds of thousands of ECGs paired with patient outcomes. And what they found was surprising. AI could predict from a routine ECG whether a patient had reduced heart function. Not surprising, cardiologists can spot that. But it could also predict the patient's potassium levels from the ECG. But potassium doesn't have an obvious relationship to the heart's electrical tracing, and yet the signal was there, buried in the data, invisible to human readers. It could also predict whether a patient would develop atrial fibrillation years into the future, before any clinical symptoms had appeared. And what's most interesting is it could predict and determine a patient's biological age, which is a measure that correlates with long-term health outcomes, more accurately than most any clinical assessments. One ECG reading, 100 years of expertise, and AI found things in it that we never knew were there. What does this mean? It means that the human body is encoding information that our theories never predicted it would encode. It means that electrical activity of the heart is somehow carrying signals about systematic aging, about electrolyte balance, about future arrhythmias, and our models of cardiac physiology did not anticipate any of this. AI didn't confirm our theories. It found something our theories fundamentally did not include. So, if an ECG contains much more information than we thought, what else are we missing? What other diagnostic signals are hiding in data we've been collecting for decades but not looking at correctly? Consider, Google's DeepMind trained AI to look at photographs of the retina, back of the eye. Ophthalmologists have long known that the retina offers a window into a body's health. You can see blood vessels there, and blood vessels are affected by diabetes, hypertension, aging. But DeepMind's AI found things that went well beyond what anyone expected. The retina, it turns out, is one of the most information-dense diagnostic surfaces in the human body. We just didn't know that because we were looking at it with human eyes and human theories. AI went looking without a theory and found signals we hadn't imagined. Here's a third example. Researchers have been developing AI systems that listen to recorded speech and detect early signals of cognitive decline, the kind that precedes Alzheimer's disease by years. They're not listening for what you say, they're listening to how you say it, the length of your sentences, the complexity of your sentences, the length of your pauses, the words you reach for, the ones you can't quite find, the rhythm of your speech. Those signals exist, they're real, and they predict Alzheimer's with meaningful accuracy years before any other clinical diagnosis can do it. But neurologists and linguists didn't know those specific patterns existed at any level of predictive power. The relationship between these subtle speech patterns and neurodegenerative diseases wasn't in the textbooks. AI found it by looking at data without preconceptions, and now researchers are scrambling to understand why that signal exists, and it's there. The biology is still being reverse engineered from AI's finding. The philosopher and the scientist in me finds that interesting or strange, depending on how I'm looking at it. Science is supposed to work like this. You form a hypothesis, you design a study, you test it, you understand the mechanism, and then you apply that knowledge. AI is increasingly running that pattern backwards. Here's a pattern, here's a prediction, here's a finding that works in practice. Now humans, you go figure out why. We're now using AI-generated insights that we cannot yet explain. And in some cases, we may not be able to explain them for years. But while the individual explanations are fascinating, the deeper implications is what should really interest us. Most clinical medicine rests on expert consensus. Experienced physicians observe patterns over decades of practice. Those observations get formulated into guidelines, protocols, textbooks. This is how medical knowledge accumulates and gets transmitted. But expert consensus actually is, when you look at it closely, just pattern recognition, carried out by individuals who each see a few thousand patients over a career, filtered through a lens of whatever theories were dominant when they were trained, formalized through committees that have their own politics and biases. So one experienced cardiologist might see 50,000 patients in a career, but AI trains on 5 million ECGs. So the cardiologist, over a lifetime, is just working with 1/100th of 1% of the same data that the AI tool is using. When AI disagrees with expert consensus, we tend to assume that AI somehow got it wrong. But we should at least be asking ourselves, what if some of our most confident clinical guidelines are actually artifacts of limited data rather than true signals? AI is starting to reveal seams in our knowledge, places where we were more confident than the evidence warranted, where a plausible theory got mistaken for a proven mechanism. Medicine self-image is of a science that understands the body and then intervenes accordingly. What AI is showing us is that the map has always had more blank spaces in it than we were admitting, and that some of what we thought was drawn in ink was actually drawn in pencil. I think the most important thing that AI is doing in medicine right now, not the predictions themselves, but it's the reminder that our certainty in medicine has always been partially borrowed. But it also goes the other way, what medicine reveals about AI. So I've just described AI findings in the human body that medicine didn't know were there. You might expect me to follow that with, and so hospitals rush to deploy these tools and patients are living longer as a result. But here's what actually happened. The average American hospital today still sends a significant portion of its communication by fax. Physicians spend roughly half their working hours on documentation rather than patient care. Many hospital systems run on software that was designed in the 1990s and has been patched and modified so many times that no one fully understands it anymore. And the AI tools that have been shown to outperform medical specialists in research settings, most of them are not in clinical use. Some of them never will be. So what happened? And I want to say as an aside, a former faculty member here in the College of Informatics, who is a good friend of mine, Gary Ozanich, who's long retired now, has been working for the federal government for the past 12 years on an expert committee culled from experts around the country to design a software system that allows your electronic health care system, your online MyChart system, to talk to the other systems from other states and other universities and medical centers. They have been working on this project for 12 years. He is going to die before they are able to get this solution correct. That's kind of the mess that a lot of healthcare systems have kind of grown themselves into, just as an actual aside, talking about using faxes. Okay, so what's happened? Why isn't AI helping medicine much more than it is right now? And there's several reasons. The first is regulation. To deploy an AI tool that makes or influences clinical decisions in the United States, you need FDA clearance. And I'm sure, as you know, that process is slow, it's expensive, and it's uncertain. It takes years. And many promising tools have never made it through because the companies that built them couldn't sustain the time and the cost involved. Others haven't made it through because by the time it worked its way up to FDA clearance, it's already been superseded by better technology. But that slowness in FDA approval is not just buggy, bureaucratic incompetence. Think about it. If Facebook rolls out a buggy update, your feed could look weird for a day. If medical AI makes a systematic error across thousands of patients, people could be harmed in ways that are hard to detect and even harder to reverse. So the caution that the FDA exhibits is rational. But it also means that most of the studies that describe these fantastic tools are not deployed anywhere and likely never will be. The second layer is the last mile problem. And that simply is a model trained on data at one institution, a lot of times just quietly falls apart when deployed at another one. And this is particularly true when you're thinking about how many of our systems are developed in Silicon Valley and particularly at Stanford Medical School. And you think about trying to implement that system, for example, in rural Mississippi or Alabama or even Kentucky. Hospitals use different electronic record systems. We've talked about that. Imaging systems from different manufacturers produce subtly different outcomes. And when you're training on 5 million recordings on one system, that may not map well. In fact, it often doesn't to the subtleties of another system. Patient populations differ. Documentation practices differ. A radiology AI trained in a large urban academic medical center is likely trained on images that are subtly different, contrast levels, scanning protocols, and the kinds of patients who present from the images at a community hospital in rural Tennessee. That difference is often enough to meaningfully degrade performance. The so-called distribution shift, if you ever read about that, is one of the most pervasive and least discussed problems in applied AI. And it means that the impressive accuracy numbers that you see in a research paper are likely just upper bounds, not guarantees. And the real-world number is often much lower, sometimes a lot lower, and no one is really systematically tracking that gap. Third problem, workflow. Imagine that you have an AI system that genuinely works. It's got regulatory approval. It performs well on your patient population. You try to deploy it, but nothing happens. Physicians don't use it, or they click through its alerts without reading it, or they find it slows them down, or it appears on their screen at the wrong moment in their workflow, and they've already made the decision it was meant to inform. The reason is that healthcare workers are among the most over-alerted humans on the planet. Hospital information systems generate just already an extraordinary volume of automated notifications and information about drug interactions, abnormal lab values, patients who need follow-up. Studies have found that physicians just override most of these alerts, often without reading them. They're not being negligent. They're just adapting to their new environment based on what they knew when they were trained a score of years ago. And the problem is with the medical profession, when everything is urgent, then nothing is urgent. So change is very slow. So dropping an AI system into this environment doesn't solve the problem, it just adds one. So making an AI tool actually change clinical behavior requires a deep understanding of how clinical work happens. And most AI developers don't have that understanding, and they don't prioritize learning it. They build the model, demonstrate its accuracy, sell it to someone who they think is going to make billions of dollars off of it, and assume the rest is just going to sort itself out, and it doesn't. Fourth issue. Liability. Who is responsible when an AI recommendation leaves to a bad outcome. If a physician follows AI's suggestion and the patient is harmed, did the physician practice good medicine, or did they inappropriately defer to a black box they didn't understand? If they override AI and the patient is harmed, were they exercising appropriate clinical judgment or ignoring useful evidence? The legal and ethical frameworks to answer these questions are still being constructed and worked out, but the rational response, if you're a clinician, is caution. We're not going to expose ourselves to any potential liability until all of this is sorted out. That's not irrational behavior, but it does significantly slow down adoption. And then finally, the business model. And I think this is the most important one and something that no one ever talks about, really. Healthcare is a fee-for-service system in the United States. That is, hospitals and physicians get paid for doing things. They order tests, they perform procedures, they see patients, patients spend nights in hospitals. And if AI makes that more efficient, if it reduces unnecessary imaging, if it shortens hospital stays, if it prevents admission by catching deterioration early, it might genuinely improve patient outcomes, but it also simultaneously reduces the revenue that the medical system, that's deploying the artificial intelligence. Those savings actually flow to the insurer, not to the hospital system. And so the cost of adopting this technology falls on the medical provider, savings fall on the insurer. And so your financial incentive program is completely misaligned. And until the financial incentives align with clinical benefits, that is, physicians are actually rewarded for better clinical outcomes, there's a large class of genuinely valuable AI tools that will be resisted, not because they don't perform well, but because of who might profit from them. Right, I'm going to skip this one. It's just a historical story about Watson. So, what actually does get adopted? The AI tools that have spread most rapidly in healthcare settings are not the ones making clinical decisions. They're the ones handling administration. AI systems that transcribe clinical conversations, generate draft notes, systems that help with insurance prior authorization, which is a big one, systems that assist with billing code selection. Why those? Well, one reason is they sit outside of the clinical decision-making loop. There's no FDA pathway that is required for a transcription tool. The liability question is much easier. The workflow integration is cleaner. The tool gives you a draft, you edit it. You're in control as a physician still. And most crucially, the financial benefit accrues directly to the institution that adopts it. If physicians spend fewer hours on documentation, if hospital systems can execute faster billing cycles and reduce administrative costs, then they will profit from those changes. AI in medicine is advancing fastest where it helps the institutions make money, and slowest where it could actually directly help the patients. That's not a technology problem. That's a systems problem, and it's a problem that better algorithms, better AI is not going to solve. Oh, already did that. So, AI walked into medicine carrying an assumption that the problem with healthcare was fundamentally a problem of insufficient intelligence, not enough pattern recognition, not enough data analysis, not enough speed. Give us the data and we will find what humans have missed. And in one sense, that assumption was correct, more correct than even the wildest of optimistic people could expect. The patterns in the ECG, the signals in retinal photography, the markers in speech recordings, these are real and finding them required computational power that no human could bring to bear, no individual human could bring to bear, and AI genuinely saw things that medicine had missed. But medicine pushed back. It said, finding a pattern is not the same thing as changing a system. Intelligence is not the bottleneck. The bottleneck is incentives and liability and workflow and trust and the 1,000 human and institutional factors that determine whether a good idea reaches a patient. And on those questions, AI developers have almost nothing to offer because they have spent almost no time thinking about them. So we have two fields. Each walked into this encounter certain they knew what they were doing. Each was wrong in ways that they hadn't anticipated, and the encounter has forced them both slowly, uncomfortably, incompetently to become more honest. Machine medicine, is learning that its theories of the body were more provisional than it admitted. That the evidence base for some of its most confident practices was thinner than it looked. That a machine with no biological understanding can sometimes outpredict a physician with decades of experience, and that the right response to that is curiosity. AI is learning that a working model is not a working solution, that humans and institutions are not simply rational actors who will adopt better tools when better tools become available, that the social, economic, and political context technology must survive in is just as complex as the technical problem it was designed to solve, and that ignoring that context is its own kind of hubris. What's emerging from this collision, slowly and messily, is something neither field would have produced on its own. A more honest account of what we know and what we don't know about the human body. A more sophisticated understanding of what it takes to change medical practice, and perhaps most importantly, a set of harder, better questions than either field was asking before they met. What does it mean to understand something about the body if we can predict but not explain it? What does it mean to have a working tool that nobody uses? What do we owe patients in a world where the best possible care exists in a research paper but not in their hospital? Who gets to decide when an AI prediction is trustworthy enough to act on? And how do we build systems, not just algorithms, but actual human systems that can get the right answer to the right patient at the right time? Neither side knows what it's doing yet. That's actually the good news. Because the alternative, two fields, each certain of its own expertise, neither willing to be humbled by the other, would produce something far more dangerous than uncertainty. It would produce confident error at scale. Uncertainty, at least, keeps asking questions. Thank you.
Hello? Is this on? Yes. All right. It's hard to tell when you're wearing it. All right, step one, I press the button. We get, aha! Excellent. All right, we're good to go. Well, hello, everyone. My name's Parker Kane. I am a pacer, so you're gonna have to deal with that. I also talk with my hands way too much. In my preparation for this, when I prepare for like a talk I'm giving or like a presentation at work or something, I will sometimes talk in my sleep, and then my wife will give me reports of what I said afterwards, which never makes any sense at all, of course. And for this one, I sat up in bed, no joke, I'm not lying about this, and with my hands, I said, we gotta connect the lines. I have no idea what that means. But hopefully we come out of this connecting some lines, I guess. My name is Parker Kane. I'm the co-founder of Ascent Data Insights. We are a consulting company here based in Cincinnati, really focused around helping companies make sense of this very interesting time we're all in with AI, trying to grasp kind of where's the right place for businesses to integrate AI or not from a healthcare perspective or well, I mean, healthcare is very regulated, so we probably aren't doing anything in healthcare, but in other businesses as well. Before that, I spent 6 years at 8451. They're the data people for Kroger, doing AI before AI was AI, kind of. And before that, I was a data science and statistics double major here at Northern Kentucky University. So always excited to be back at my alma mater. Today, we're going to be talking about agents and vibe coding. These are two words that, depending on where you're getting your news or your information, you may be hearing more and more about recently. And so we are going to break it down and understand what an agent really is, what is vibe coding, and what does it mean for both the regular person, the non-technical person, but also what does it mean for the business world. So let's get going. But first, most importantly, let's take a quick break and start a business. That's what we're here to do, right? So I know we didn't expect crowd interaction or crowd work in this series, but we're going to get just a little bit. We are going to come up with the name of a business, the colors for our brand, and what people are going to do on our website. Okay, so can I get a name of a business, like a dog walking, pizza delivery, anything? Someone. We are Domino's. Yes, we are starting Domino's 2, the better Domino's. Colors for our brand. What colors should Domino's 2 use? Red? Blue. Red and blue. Great. I don't know if those are complimentary at all, but we're committing. What should people be able to do on the site? This seems like they should probably order pizzas, see our menu maybe, locations. We'll go with that. Pay, the most important thing. All right, let's go start our business. So what I'm going to do here is I'm going to pull up a tool called Claude Code. Claude Code, if anyone isn't familiar, is a tool that people use for vibe coding, which is essentially, we'll talk more about it. So maybe I'll hold on that section. See if I do this, and then I drag this over. We do this, and then this comes over here. Yeah, great. So I've pre-written a little plan for us. And so what we're going to do is, what we're looking at is just a document on my computer. We're going to fill in some information about our business, and then at the bottom here, I have provided some technical details for Claude Code about how we're going to make our website. They're not important for the sake of this demo. Honestly, a lot of what I did was tell it that this is a demo and not like a real business I'm trying to launch, so don't get too complicated. So we'll come up here, and I'll come into the business section, and I'll say, we are making Domino's 2, the better Domino's. I hope we don't have a Domino's sponsorship for this talk. Red and blue are our brand colors, what users can do, pay us money, buy pizzas, see our locations, see our menu. That sounds good. And then this is just for fun, just to get you guys thinking about the kinds of things these tools can do. We're going to throw in a little bonus feature, fully functioning snake game. You know that snake game you play where you hit the arrow keys and the snake chases a little apple and then it gets longer? We're going to get one of those. I can play with my arrow keys. Excellent. That's everything we need. And so now we've edited our file. I'm going to open Claude Code, and I'm going to tell it, please take a look at plan.markdown, the file I made, and execute the plan. All right, while our business is cooking, let's get talking. So let's back up. Let's say, I want to start by grounding us in how AI worked back in 2022 when ChatGPT first launched. I think it was November of 2022. If I was a user who did something I always want to do, which is get pictures of cats, and I went to the 2022 version of ChatGPT and I asked it to please draw me a cat, this is what I would get. This is a text representation of a cat. It is not a picture like an image of a cat. It doesn't go out and get me an image of a cat. It doesn't draw me with like any of the fancy image generation tools. It would actually just try to give me a cat in text form. And that was the best it could possibly do. Fast forward to 2026 ChatGPT. So we move 3.5 years into the future. And if I ask ChatGPT to draw me a cat right now, what I get is a very different cat. I get something like this. This is actually what I asked it. I was trying to count earlier, because AI image generators, one thing they always get wrong, or at least historically got wrong, is they would give people like 6 fingers or 7 fingers. I was trying to figure out how many toes this cat had. I couldn't quite tell. But it's doing a lot better. That's a pretty convincing cat, completely AI generated. And so the question is, what has changed between these two systems? We have the 2022 version of ChatGPT that is only capable of working with text. And we have the 2026 version of ChatGPT that is able to do a lot more. So let's zoom out and generalize a little bit. When we're talking about any large language model, which are the models that underpin these AI systems, really the way they work is a user comes there, they type in some text that gets fed into the large language model, and it produces some output text. Right? That's the 2022 model. I feed in, draw me a cat, and it feeds me out a text representation of a cat. So, given this, how do we get a cat? Where's our cat image? What is making that happen? How have the systems gotten more complex such that we are able to actually get a true image of a cat instead of just text? I'm going to quickly check on our business. We're okay, everything's going to plan. Excellent. Don't worry about that. We'll come back to that. So the answer as to how these systems have gotten more advanced is what are called tools. And tools are really just something that a software developer, one of the big model providers like OpenAI or Anthropic, it is them building functionality into a large language model to allow it to perform specific actions that have an effect outside of simply predicting or generating text. By default, all they can do is generate some text, and so a tool allows them to do a little bit more than that. So anytime you are using a modern AI platform, I mean ChatGPT, I mean Claude, I mean Gemini, I mean Grok, I mean any of these AI platforms, really the way they work, if you go to ChatGPT right now, is they have tools that OpenAI has built on the back end such that when you ask for them to generate an image for you, they reach out and use a tool instead. And we'll talk a little bit more about that in a second. And so now to define agents, really any large language model that has access to tools, has access to do some impact on the world that isn't just generating text, is an agent. I will put an asterisk on this because in the world of AI, everything is made up, and by that I mostly mean it's all moving so fast that really there isn't a standardized definition of agents. I double-checked like 4 different places. And really, depending on who you ask, people are going to say different things are agents. This is the definition that I am going to sit upon as a practitioner and someone in the industry, but there are definitely variations of this, depending on who you ask. Okay. So let's bring this to life a little bit. And I want to do that by giving you some examples of tools. Quick business check, we're still cooking. All right. And so here's one example of a tool, which is image generation, as I was just saying. Really a tool, you can think of it as it has a description of what this tool does, and then it has some inputs that people have to provide, and then it has some response that the tool gives back. So in this case, our image generation tool, it generates an image using an outside model. So if anyone has ever heard of DALL-E or Midjourney or Stable Diffusion, there's dozens and dozens of these now. Those are image generation models. Their whole job is that you feed in something like draw me a cat, and it actually makes the cat model. So what we need to feed into this tool is the description of the image we're going to create. It's the name of that model that we want to use, whether it's Midjourney or DALL-E or something else. And what it's going to give us back is either success or failure. Did we successfully make that cat image? And then also it would need to link back to that image so that then our model kind of knows what that image is. Second example, and this is extremely common. If you've ever gone to ChatGPT and asked it for the score of a sports game or something like that, if you did that in 2022 and you asked it for a sports game that was currently on, it would say, I have no idea, or it would make something up, even worse. But if you do it now, it will actually go get that information. It'll go hit ESPN, for example, and figure out what the score of that game is. And so it's doing this with a tool to go get information from the internet. So the description of that tool might say, this gets all the text content from a website. The inputs that you need to provide are the URL of that website and how much content we want to pull back. If the website's really big, maybe we don't want to pull back the entire website. Maybe we want to pull back 1 or 2 paragraphs. And then the response that we get from that tool is success or failure. Again, maybe something was wrong, the internet was down, we couldn't reach out to ESPN. And then all of the content of that website as text. And our last example, executing code. This is where things get really crazy. Because you can think image generation, the side effects there are pretty minimal. We get an image and that's it. Even scraping a website, the side effects are pretty minimal. We get some text back. When you start to talk about doing things like executing random code, then the side effects that you get could be much, much larger, right? They could access totally different systems. They could create data. They could destroy data. They could do all kinds of things. And so this kind of tool, very generic, you might just feed it some Python code that you want it to execute and how long you're going to wait for that code to run. Maybe it's 5 seconds, maybe it's 10 seconds. And then it will tell you back, did the code execute successfully? And what was the result of that code? So all of these are examples of different tools that you can use, or that these AI systems can use to have impact on the outside world, outside of just generating some basic text. Now, we're going to go back to our cat example and add in some tool use to hopefully bring this to life. Checking on our business. Oh, we're bug fixing. Nice job. Oh, we're done. Excellent. All right, we're good to go. We'll go there later, don't worry. Okay, so for our cat generation example, let's say I go to ChatGPT today and I ask it to draw a cat. What really happens here is it thinks to itself, and I know that's crazy to say, but yes, it thinks to itself a little bit. The user wants a cat picture. Do I have any tools that I can use to do this? And it looks at the tools that have been registered to it, and it says, hey, I have a generate image tool. And so because I have a generate image tool, that sounds exactly what I might want to use right now. And if there wasn't a tool that we needed to use, then the alternative is that I would return just some response to the user that says, hey, I don't know how to do that, or I would draw a text image of a cat. So we reach out to our generate image tool, and what that does is it makes us an image. Again, once we're in this top right box, we're actually completely outside of the large language model now. This is a completely external thing. And it will go generate a picture of a cat, and it will return the text, hey, your cat was successfully created, which is great news. And that feeds back into our large language model. So now our large language model has both the history of the conversation we were having with it, where we were asking for a cat, and it also knows, hey, I successfully generated a cat. So it comes back around and it says, wait, I don't need to generate a cat anymore. I have a cat image ready to go. And then it asks itself again, well, do I need to use any more tools? And in this case, because we already have our cat image generated, we say, no, we do not need to generate any more or use any more tools. And so we're going to go give our cat image back to the user. And importantly, this part where we're using a tool can actually happen in a loop. Like I said, we might use an image generation tool the first time, and we might use a completely different tool a second time around. An example of this is, let's say I wanted to generate an image, but not of a cat. I wanted to generate an image of the Red Stadium with the score of a baseball game that's going on right now. And so what it would need to do is two things. First, it needs to go reach out to ESPN or wherever, get the score of the current Reds game, and then it would need to send that information to the image generation tool. So this little section here can actually happen in a loop, over and over and over again. It kind of thinking, using tools, getting more context, getting closer and closer to solving the problem we actually asked for. So we can generalize this. And this is actually a well-known thing in the AI space. It's called an agent loop. And this is really the foundations of what makes any agent an agent, is a user feeds some text to a large language model. We go through a little loop of using tools. Eventually, we get a satisfactory answer, and we return our response to the user. And then importantly, this loops back around again. If any of you have used ChatGPT before, you ask it for a cat image, and it gives you a cat image, and you say, no, I wanted a calico. And it goes, okay, I'll give you a calico. And it will go and repeat again. And so this conversation can repeat and repeat and repeat. So this right here is kind of the bedrock of why AI agents are so much more powerful than they used to be. Back in 2022, really the only thing that you had here was any of these horizontal lines. The user talks to the large language model, which then returns a response. This idea of tool use now means that these systems can do all kinds of other things, like generating images, like reaching out to the internet, like running arbitrary code, or in our case, building Dominoes 2, the better Dominoes. So, speaking of which, are we ready to go? Are we ready for Shark Tank? Let's see. So I'll just go ahead. I'm not going to go into this in too much detail, but you can see, hey, we've built and deployed Dominoes 2 to Dominoes 2. Fun fact, this link would actually work for any of you. So if I take Dominoes 2, go ahead and copy that, go over to my browser, and type this in. I'll pull it over in just a second, don't worry. Here we go. And this right here is Dominoes 2, the better Dominoes. Hotter, faster, tastier. In beautiful red and blue. And so you can see here we can pay us money. Pay now. I assume this doesn't actually work. I hope not, to be clear. We can order. We can see our pizza options. The Meat Destroyer. Sounds great. And then we can see our locations here. Oh, we're in Los Angeles. Yeah, we did not start at home. And then here's our, it's a different version of our menu here. And then just to get weird at the end, look, here's our little snake game. Oh, I gotta be ready. Here we go. Look at that. Oh, it's a little pizza emoji too. That's so good. Yeah, this is wonderful. All right, well, this is the whole rest of the talk. Got to get that one. All right, enough of that. So that's crazy, right? What you just saw was we typed a little bit of stuff into a document. We told Claude Code, go make a website for us. And I'm not joking, that URL is live. If you pulled that up on your phone, you would see the same thing. It might look really bad, not be formatted properly. But that is a real website. And so, as you can imagine, that has pretty huge implications for software developers and entrepreneurs. And all of this, at the end of the day, is using that same loop, that same agent loop that we were talking about for cat generation. So let's talk about how that agent loop looks. Checking my time. All right, we're getting a little low. I will keep us moving. So this is what our agent loop looks like for a coding agent. The basic idea is exactly the same. A user, that was me, I made a file. That was just my way of getting a whole bunch of text in at once. But it's the same idea. I fed some text into a large language model, and it had some very specific tools, Claude Code does, where it can maybe create files, it can edit files, it can execute some code, and it can also deploy our website. And there's a whole bunch of other ones, just to be clear. And then it loops that for, I think it said about 6 minutes. And then eventually, it successfully deployed the website, and it said, well, looks like we're good to go. And it returned that final response to me that said, hey, here's Dominoes 2. And so if I hop over here, let's see if I can do this. I'll give this one shot, and if I scroll up a little bit, here's it writing a whole lot of code. Yeah, this is the fun part. Each one of these writes you see, that's it using the write tool to write a file. Each one of those is a different file that it created on my computer. And so it looped, looks like dozens of times in order to create all of the code that it needed to be able to generate this website. And it did all of it without me doing anything. How cool, and also terrifying. But cool. And so this, what we've just described, is the process of vibe coding. What we did was we described the end state. I want Domino's 2. Please make this a thing. And it created that software by me not writing a single line of code. I am a software developer, but I gave some technical specifications, but honestly, we could have ignored those entirely. It might have just taken longer, and I might have had to prod it a little bit. But if you had come in and just said, please make me a website, the way Claude Code would have worked is we just would have asked you some questions about how do you want to make the website, and do you want this or that? And I kind of provided that all up front. So this vibe coding idea is the idea that a coding agent can now produce decently high quality software without anyone writing any code at all. So let's talk about the implications. I am wrapping up here, I promise. Implications for people. First, these agents are going to democratize technical skills. As you can imagine, you do not need to be a software developer to do what I just did. And there are tools. Claude Code markets a little bit more to developers. It's kind of meant to be like a power tool for software developers. There are versions of Claude Code, things like Lovable, if you look up Lovable, that is essentially Claude Code that they take a level up. And it's really designed for people that do not write code at all. And so you can now imagine that regular people, all of a sudden, if you want to go and you say, I always forget when to water the plants and when I water different ones at different times, and you went to Lovable, and you say, can you make me a website to track when I water my plants? It'll do it. And it's reasonably good. Little things like that, little everyday automations are actually totally in reach for people now that maybe historically you would have needed a technical background to be able to do. Second, highly autonomous agents are going to be super common in everyday lives. If you are calling a customer service representative right now, I'd say it's like a 50-50 shot that you are not, like, I know there's the versions where it's like, press 1 to talk to something. What I mean is like a convincing AI agent that you think might be a person. Those are going to be pretty much the standard for things like phone customer service, if they're not already. Like I might be convinced half the time as well. And so things like booking, I think specifically there's a world in which in the next couple of years, personal assistants are going to get particularly good. Things like Siri and Alexa that you're carrying around right now that are like mostly good for starting timers and music, are going to be agentified. And all of a sudden there's a world in which you're like, oh, make me a reservation, book me a flight, that kind of stuff. And these things are operating totally autonomously for long amounts of time. My third one, and this is where things get a little scary, I'm sorry, but highly personal content will become extremely cheap to produce. What I mean by this is if an AI agent can just run in a loop and produce tons of content, imagine a world where, say, I'm trying to advertise something, and I say, instead of producing one advertisement, what if I have my AI agent produce 10,000 versions of that advertisement for every segment that shops at Domino's 2, right? I want to appeal to the busy parents that want Domino's 2 on the way home from work, and I want to advertise Domino's 2 to businesses that need it for their next outing, and that sounds pretty like calm, everything's fine, a little bit of personalized advertising. What I'm more worried about is a world in which social media and algorithmic feeds, everyone is getting fed their own version of content. That is a world that I think we could be heading towards, and it will only accelerate the fact that I think we're already kind of in bubbles of our own. You hear things from people that are like you, and this could all of a sudden make it that you only hear things that are exactly for you. And I think that's a real danger to our sense of community and just like the conversations that we need to have as like a society. So that's a thing. I ain't got no answers. Only problems here at the Agents Talk. But there's some exciting stuff too. That other stuff was exciting. And I think the business world is really exciting too. This is my last slide, I promise. First of all, this is the one I'm so excited for. It's part of the reason I started my own business, is we are entering just a golden age for entrepreneurship. You have an idea of a business, and the technical barrier for entry has never been lower, right? Your ability to produce the websites and the social media content, and like I said, the advertising that is actually fine-tuned for different audiences. This is amazing. And I think it means that there's going to be a whole generation of entrepreneurs that is created and enabled because of AI agents. Second, and this kind of goes with that, is smaller teams are going to be able to accomplish much more. What maybe you needed a team of 15 for can now be done by a team of 2 or 3. And I think that's really going to benefit small and medium-sized businesses to be able to get done a lot more for a lot less, which I think is just great for our business economy. And then lastly, the moat for businesses is no longer going to be, well, we built it, and that's hard. And now we get all the business, right? Because building new software is going to be much, much easier. So the moat, the reason why people continue to use your business, is going to be the data that you have on your customers, because that's hard to get, and also really excellent customer experience. The businesses that determine that, hey, we actually don't want to have an AI answer our phones because people hate when the AI answers the phones. What we want to use the AI for is automating our back office so that we do less paperwork. And that doesn't negatively impact the customer at all. It makes us more efficient. So I think it's just going to be, in the business world, just like a pretty exciting next forever. And with that, that's all I've got for you today. I hope you had fun. I had fun. That's my email, in case anyone wants to say hi. And now I'll hand it back off to Dean Kevin Kirby.
Thank you, Parker. Thank you, Valerie. So we actually do have some time for questions. I do want to show you 2 credit slides. The BPAI support team, Epi Madison, Casey, whose first name I misspelled, I just see now, I'm sorry, Norse Media, Joe Wendell and Nate Brewer, thank you. It takes a team to make this possible. And you said clicking?
This is my laptop.
Oh. It takes a very generous philanthropist, so thank you to Ellen Revachol for making this happening. So the plan now, we will take questions. Dr. Hardcastle and Parker will be available to answer any questions you like over the next time. We will end a little bit before 4:30 because I will then turn it over to Professor Estep, who is going to give you a preview of what's coming in this room in the hands-on session a week from now. So Joe, is there any way we can turn up the house lights or something so we can see who's out there asking questions?
Yeah, Casey and I will take the mics around.
Simple question. The Domino's example, was that by free chat GPT or did you have to pay for that?
Test. That was using paid Claude Code. Claude Code is available for free, but it's not particularly good unless you pay for it. So that was paid.
The $20 a month model?
$100 a month.
Okay. I get good stuff for $20 a month.
Yeah, it's the same quality of model, it's just how much you get to use it.
A question for Parker and a compliment to Dr. Hardcastle. She ended her talk with the barriers. Even though we were excited about what AI can do in healthcare and medicine, she talked about the organizational barriers. You were optimistic and made it sound like there are no barriers to eliminate coding and technology in the world ahead. Is that true? Is that what you meant to say?
I would say, so I think the barrier for entry is much, much lower. I think the barrier for excellence, I guess is what I'd say, is pretty much the same. Like, I don't think that software developer jobs are going away anytime soon, because as you could see from Domino's 2, that was a step away from what I'd say the quality of the actual Domino's website is. And that difference, I think, is pretty big. And so I think there are still quite a lot of barriers and areas where you would want to bring a software developer in that really knows what they're doing. But I think it's mostly the barrier to entry that is much lower.
For another day, perhaps. I'm imagining marketing people at Procter & Gamble doing all those advertising, and they don't need a technical person, but they need something. Otherwise, we'll see 1,000 Pampers ads with different babies. Is that a barrier?
Are you asking essentially like what? Okay, we can, I'll grab you.
Okay, I just have a question about some of the terminology. Why is it called vibe coding? What's the vibe part?
Yeah, that was Andre Carpathy, who is I actually don't, where does he work? What's his thing? You know Carpathy? Yeah, I think it was Anthropic. But he gave a talk where he coined that phrase, and what he means is like the vibes, the feeling. Like you're just sipping a drink and like hanging out. Like you're just letting the system do everything for you. That's kind of what he means. Like the great vibes of sitting on a beach, that kind of thing.
All right, and a couple of in the coding list that you showed, I've never heard what is bashing and what is whirlpooling.
Yeah. So bash is like it's a computer science. It was executing a command on my computer. Bash is kind of how you do that. So it was using a bash tool. The whirlpooling part, the Claude Code people, they have a sense of humor. And so when you are like waiting for responses, it has a list of about 100 or 200 little verbs that it pops up. So it would be like whirlpooling or it's got a polarizing or whatever. Like it's just got a whole bunch of them. So that one meant nothing.
Wonder if you could help me understand. There's been a proliferation of data centers, right? I mean, they're all over the place, and there's a lot of money that goes into creating these data centers. Somebody's funding that. What's their gain? What's their financial incentive in doing that?
Yeah.
What are they hoping to?
Yeah, they're hoping, I think, the reason why there's like $1 trillion valuation for OpenAI, we're also in full speculation time. This is just my opinion. But that they are hoping that these frontier AI models reach superintelligence. They reach the ability to improve themselves faster and faster and faster, and all of a sudden these models get better than any human has ever been in anything and ever will be. And so then all of a sudden that's worth $1 trillion to them, because you might have bought 100 data centers, but inside of that data center is I think the term from Anthropic is a country of geniuses in a data center is what they aspire to build.
Two-part question. You mentioned the diffusion thing, and that's a tool, I guess, and I'd like a little expansion on that. But the only time I've done anything like vibe coding, it was to translate from one language to another. It's not anything this sophisticated. But I was wondering, how do you envision people maintaining code? And I guess that would get into the ethics of, well, if the code causes a liability issue, then who's really responsible? You know, so that's my two-part.
Yeah, that's an area where it ties into Valerie's talk really well. Is I think healthcare is going to be the last place that any of this enters, right? Because of the liability issue. It's definitely a big question of. It's a hot debate in software development right now of how much can you let your hands off of the wheel? How much can you vibe? Are you really going to have a code base that is a production system that people rely on where none of your software developers have ever looked at the code? Right now, the answer to that is no. You cannot do, you kind of, my take is maybe you can have Claude Code speed you up, but it's your responsibility to go back in and edit and make sure that you understand that code. But as the tools get better and better, is that still what people are doing? And I think there are definitely companies right now where people are totally letting their hands off the wheel.
Can't the government put caps on reliability if a physician used AI and there was an adverse outcome? Would you have caps on personal injuries anyway?
Well, yes. I think the question, I think it immediately becomes a very complicated question, because using AI is not like looking something up in a book. It's using the tool And so, I mean, you can compare it to any sort of tool, using a microscope. But if the microscope is flawed, and then the doctor makes a poor decision based on that, you know, how do you pass the liability? How much you rely on the tool? I think it just gets very complicated, very complicated very quickly. And I, you know, take the implication of your comment seriously. It'll get worked out, just like all other liability gets worked out. And it will.
If Medicare is using AI for decision making that can decide, I don't need a heart transplant, you know, I think there's a way to have a round table to fix some of these potential issues.
No, I agree. I agree. We're not there yet, but I certainly agree it will come.
The majority of medicine is administered not by the physician, but by nurses, pharmacists, other practitioners, and so forth. How the heck do you try to coordinate this?
Well, I guess I would, if I were to predict, I would say the physician is going to become even more removed, because if you're integrating AI systematically into basic healthcare, then you don't need the physician's expertise. You just need someone's expertise who can interact with the patient, that particular patient population. In many respects, that's already what you're seeing with APRNs and nurses and nurse practitioners and so forth, is they are figuring a way to manage a lot of healthcare without requiring the MD level of expertise to accomplish it. So I think what we think of as an MD will just become scarcer and maybe at some point not necessary for the implementation of sophisticated healthcare decision making.
Is it my turn? I have a question for Parker. First of all, on the issue of marketing, social media, what have you, with AI, could you envision, like one of the things we all get in the mail is junk mail, and we all are really sick of it. But could you see a version of junk mail produced by AI that has all your personal information and creates ads, like these little paper ads that have very, very familiar faces, let's say, you know, because it's scanned your social media and it knows who your friends are and it knows, you know, what you've been talking about recently. And suddenly you have like targeted individual ads that are just below your radar, that it's not obvious that they've been listening to you and watching you. But I mean, is that something you could actually see happen, do you think?
Yeah, that's the nightmare scenario, but yeah. Yeah. And I think that take it a step further is the cybersecurity implications, right? What if instead of it being an advertisement, it was a phishing attempt, right? Like, and it was something that looked great. Normally, I've worked at a company where they send you like the test spam messages where it's like Microsoft and the link is spelled wrong and you catch that and you say, I got him, you were tricky. Like, it's gonna get so much more sophisticated. And so I think both the individualized ads piece, but also individualized like hacking attempts. Yeah, the cybersecurity world is gonna be so important for all of this.
One last quick binary question. Did you know that on Shark Tank, the guy won a deal who had a website to draw cats for people? I'm not making this up. Look it up.
Bring my wallet.
He had a song, I want to draw a cat for you, blah, blah, blah.
This question is for both of you. Given the amount of data that not only the AI systems are using, but also businesses and medical personnel and so on and so forth to do this kind of analysis, do either of you see that data as a communal resource or an individual resource where the individual can decide to opt out and not give their data over to a company?
I think even today, it is harder and harder to opt out in any sort of meaningful way. I mean, I personally live as big an unlisted life as I possibly can for historical reasons, not because I don't like technology, but it has a very complicated past that I can tell you about, kind of nefarious and weird. No matter. But I can tell you that as unlisted as I try to be, I am inundated by all types of things. And so I think it's just not going to be possible. And we will, even now, right, I have these skimmers that try to get rid of all of the junk email that I get, and I go through it, and it takes me 20 minutes just to read the headlines. And that's just going to continue to get worse and worse. And the more they filter, the more sophisticated people will get. I think it's just going to be a circuitous pattern that we have to deal with.
Very much agree. I think it's a cat and mouse game, and it's also, I think, very savvy people will find tools and find software or whatever it is that chooses not to track you as much, and you can opt into that. For example, like I pay $20 a month to use a search engine with AI built into it that is not Google. Google does quite a lot of tracking. It's also very good and very free. And there might be people that say, I'm willing to pay $20 a month for a version of Google that doesn't track me. And so that, I think, is always going to be a dynamic. I think, unfortunately, as you said, like the free option, I think is going to be very tracker heavy, because that's how they subsidize the creation of that thing. But I think there could absolutely be a growing market for more private solutions, and if people are willing to kind of put in the time to find them.
I have a question. Do you worry about humans becoming dumber as we don't do the actual work?
Yeah, I mean, look at me. Yes. No, I'm kidding. I think it's a very good analogy I heard from a podcast, which is where all the best information comes from, is that you have to think about it like weightlifting versus forklifting. Weightlifting, when you're weightlifting, that is not the most efficient way to get the weight off the ground. You're doing it to make yourself stronger. Forklifting, that is the most efficient way to get the weight off the ground, and there is time for both. And so I think it is the answer to your question is yes, I'm very concerned about it, and it's going to require a level of discipline to decide when are you weightlifting in the same way that you take tests in math class without a calculator to learn how to do your times tables, and then when are you forklifting, and when do you reach for a tool that's really powerful, and how do you strike a balance between the two?
I also think our understanding of what counts as being sophisticated or skills that we know or something like that are going to change. I'll use an example. When I had my youngest child, they still taught cursive in school, and they had to learn how to write cursive. My oldest child, when I had my youngest child, they taught keyboarding in school. He does not know how to write cursive. Some people lament, oh, he does not know how to write cursive. He is a very successful adult male who is over the age of 30, and he is doing just fine keyboarding. I don't see that as a particular loss in skill. I know how to sew by hand. My daughters do not, nor does my son. I actually don't see that as a loss in skill. So they can do things that I can't do. And so I think some of it is just a question of where we put our time and energy, and do we need to keep skills that we don't really use anymore alive, because that's how we did it in the old days.
Great point.
This is more of a comment, and I'm sorry that we weren't able to be here last week with the philosopher here, which is, again, my strength. But one of the things I keep thinking about when I look at AI is it's just got the same problem we've always faced, which is the logic of induction is limited. You're never going to get certainty. That's the whole problem, and of course, it's just compounded because we're lulled into believing that it's more accurate because it can do more flip-flops of data bits than we can possibly. But it's still, the old problem of garbage in, garbage out. And there's no way, I guess sometimes with this, because it is as sophisticated, to want to doubt it. Even though, and how do you test it? I mean, where's the falsifiability? How do you figure out that, okay, we've got an EKG that's telling us that we can now tell you how biologically old you are? Well, how do you test that? Mm-hmm. With another AI? I mean, all of a sudden, it becomes circular.
Right. Yeah, I think this is where the concept of human in the loop becomes so important, is that at least for now, and as far as I can throw a stone into the future, is essentially as you start to build these AI systems into like more autonomous things, the idea is where are these critical points that you need to have a human there that says we actually can test this thing, right? Like we can compare the performance of that AI system to when we had a bunch of researchers do the same thing, and we can have them compare notes essentially. And so where do you fit these humans in the loop at these critical decision points to try to reduce some of that concern? But the problem will exist.
Then I'll get back to a different thing. When you were talking about a book, you've got, you know, the index where your sources are listed. With this AI, you don't know where it's data scraping from. How do you check the sources?
Yeah. And I mean, the answer is it's complicated, because like you can ask the AI systems like, hey, give me your sources, and it will list you the sources that it said it came from. You can never be 100% certain that that source is actually what it used. You can click on the source and say, well, I found the paragraph that sounds like what it said in the response, and that might be good enough. So I found that type of like citation stuff is at least good enough for me, but is it good enough for research or medical professionals? Like, that's a whole different question.
Yeah, but of course, that's a human problem too.
Yeah.
That's the human problem too.
Good point.
I have a question for Dr. Hardcastle. One of the obstacles that you mentioned was the disconnect between folks working in the AI world and folks working in the clinical world. It's reminiscent of what we went through when electronic medical records first became prevalent, and there was certainly a disconnect between the two worlds. What I remember of that time, it took people who could speak both languages to handle that hurdle. This seems a lot more complex than an electronic medical record, but any thoughts to how we could overcome this hurdle like we did with EMRs?
I do not have any good thoughts. I hope you do not work in the medical electronic records world, but I find it to be one of the most illogical and cumbersome systems I've ever encountered. And I cannot believe it has not advanced in the past 25 years that I've been involved with it in one fashion or another. So I hear you. I believe there should be some obvious solutions to this, but I don't know what they are. And obviously smart people have not found them yet.
As an
Thank you.
anecdote, those digital healthcare records are so infamous as being so messy that as a software person with absolutely no medical background, I know that they're crazy because everyone talks about it.
Okay. With that, maybe next season we have more time for questions, but I don't want the afternoon to be over without Professor Estep giving you all a preview of what you'll see if you come back here 1 week from now.
Okay, so you know how Dean Kirby said previously on, so in the next episode, here's what you're gonna get. So next week, we will have a hands-on session where we will be breaking down, Parker teed it up perfectly. He talked about prompting, he talked about image generation, he talked about vibe coding. We're actually gonna talk about all three of those things and a whole bunch of other things that you guys will have the opportunity to try. The vibe coding will be definitely not as complicated as what he did, but you will have the opportunity to create a game or a little to-do list, things like that, that will give you a chance to see what that looks like. So when you guys come in, if you've registered for it, you'll bring a device, you'll get an email this upcoming week with some instructions. So we're asking you to create an account we'll start with ChatGPT, and then when you come in, you'll see on the table, we'll have 3 different pieces of paper, a beginner, an intermediate, and an advanced. That's okay. I was wondering if it was me. That will kind of walk you through some of those activities, and I will guide you through them as well. So this is our opportunity to really get our hands on the tools and for you to get some experience with that. And we will have several people walking around to help you with those things. So I'd encourage you, if this has inspired you to say, hey, I haven't done a lot with AI, or I've done some, but I really want to dive a bit deeper into that, that's what next week is really all about. So I encourage you to come back. Again, you'll have a device. To be honest, a laptop, a Chromebook, something like that is going to work a little bit better than probably an iPad or a phone, so you can really really get into those tools in a little bigger screen. So I look forward to seeing you guys next week where we can get some experience with this. Thank you.
See you next week. Thank you for coming.